Hi, I'm Debbie with Nixene Publishing, and today we're continuing our discussions about graphene, and we have something that's very different. First of all, let me introduce who's here. We've got Adrian Nixon coming to us from Yorkshire, England. Hi, Adrian.
Hello, Debbie.
And we have Kevin Weir coming to us from South Carolina, right, Kevin?
That's correct. Glad to be here.
It's nice to have you. And Kevin's with General Graphene. So we are going to emphasize today that, just barely over 15 years ago, it was considered impossible to isolate that single atomic layer of graphene. And we're going to be talking about something that's really surprising. Adrian, can you talk about where we're at with graphene right now?
Yeah, just very briefly, what we're going to hear from Kevin in a minute is not this stuff. So you remember, this is the graphene I made a while ago, and that's graphene powders and dispersions, which are used in lots of commercial products, and our videos talk about that a lot. What we are going to talk about today is sheet graphene. This is graphene that's made as a one-atom thin layer on copper foil, and this is very high quality graphene made by Groltex, also in America, in California, I think, Kevin, aren't they? Kevin's company has taken this process a big step forward, and that's what we're going to find out a little bit more now. So it's sheet graphene, not powdered.
Well, Kevin, I understand that General Graphene came out of research done from Oak Ridge National Laboratory. Is that right? Can you tell us a little bit about the company?
Oak Ridge National Lab got funding for doing all sorts of different kind of single atomic CVD and technology development. And Ivan Falusik, who's now our chief scientist at General Graphene, he was working at Oak Ridge at that time and wanted to develop, I believe the genesis was trying to do a desalination membrane, which he was successful in doing and wrote a paper on it at the end. And he needed graphene, and he needed sheet graphene, and he couldn't get it anywhere. So he's quite a remarkable guy. And rather than complain, he said, this can't be too difficult. And so he produced, within a short period of time, the very first atmospheric CVD graphene. He just did it in the lab. So, okay, I've got it now. And I think people were like, how did you do that, Ivan? And but it's a true story, and when they realized what he had done and the quality of that graphene, then another spin-off project became how to turn that into a proper process and refine that process, and there was a paper written on that which has been published. So that was great. Shortly after, ONL had the opportunity to license that out, and Vig Sherrill, our CEO, a serial entrepreneur, electronics guru, and scientist himself, jumped all over it. He loved this idea. He won the award for the commercialization, and then went into the huge hole of trying to get funding to make this happen. That began maybe 2015, and between 2015 and now, we're just on our Gen 3 equipment, which is now an open 14-meter long roll-to-roll graphene industrial process. I believe it's probably the largest of its kind, and we should be able to produce if it's both sides, 100,000 square meters of graphene annually. And Gen 4 is going to be multiples of that, is already on the drawing board. So our whole drive as a company is to take this idea that Ivan had and industrialize it, so industry can really be confident that they can get the amount of graphene that they need at the consistent quality batch to batch that they need, at a cost that's affordable for their end users. And until now, that's not been possible. And that has been basically the reason why CVD sheet graphene that you mentioned, Adrian, has not come to the fore. But we're at the tipping point, and we're ready to go. We do have scalable, an industrial process that's scalable.
So what you're saying, Kevin, then, is you've hired really clever scientists from Oak Ridge, and you got them working with you. You now have a machine which can unreal a copper foil through a long furnace and coat it with a single atomic layer of graphene and do that continuously at industrial scale and roll it at the other end.
That's right. And this roll to roll is critical to get the cost down, because graphene synthesis in the traditional low pressure systems is a batch process, and scaling that is not easy. So our process, so yes, we do roll to roll. we get standard copper foils. We pre-treat and electrochemically treat those and pacify and anneal the copper before it goes into the high temperature process.
Yeah.
And the high temperature process then decomposes hydrocarbon gases, which essentially deposits as carbon, single atom carbon, onto that copper surface. We also, the copper atoms then expand and grow into crystals and migrate across the surface. So the whole of the copper sheet is completely covered with a single, like chicken wire, of atomic carbon atoms, and with the amazing properties, 2D properties that graphene delivers. And I'd also just like to mention, copper's not the only material. You can use lots of different transition metals to grow graphene on. We also use nickel, and nickel has a slightly different chemical process to copper. It's more absorbing, and therefore when you use nickel, substitute nickel for copper with different conditions, you can get multi-layer graphene, high quality graphene, as multiple sheets on top of each other at the same time, also roll to roll.
Now, Kevin, that's all fine and dandy, but other companies can do this as well. What about taking the graphene off the copper onto another substrate? Have you cracked that?
Yeah, so we're working. So you know, what do you do with the graphene? It's got to be useful. So if you're talking about lithium-ion battery, for example, and you want to get into the anode space, the copper foil that you put through is directly rolled up and used. The same in electronics. If you want to improve corrosion or the conductivity of wiring or copper plate in electronics, we can take those copper rolls straight off the line, send it to the electronics or to the EV battery manufacturers, and they can use it as is, and it's a useful product. But a lot of the time, if you want to put it on other substrates, plastics or silicon or whatever, you need a transfer process. So in this case, we are perfecting the process right now of pulling that single or multi-layer graphene off the substrate, the nickel or the copper, onto a polymer backer, and rolling that polymer backer up. That polymer backer will be given to, for example, an aluminum producer, if it's a cathode, who can then take that polymer with graphene on it and reapply it to the aluminum and produce an aluminum collector ready for putting the cathode material on, in an example of a battery. But whatever industry, that's the idea. If they don't need the graphene on the copper or the nickel, we will stick it on a transfer medium, market the transfer medium to them, and they can put it on in factory themselves. And this is not done today in the industry, so it's a real move forward.
Yes, I agree. So you can make the graphene on the copper, and then you can transfer it off onto other substrates and do other things with it. That's pretty impressive, isn't it, Debbie?
It's amazing. Yeah, it's something that, well, can we use the fantastic phrase of going from impossible to industrial? I mean, in just over 15 years, my gosh.
Yep. So we always consider, so when Vig took it over, his comment was, graphene is no longer a kind of a scientific problem. It's an engineering problem, right? And the engineering is not new in terms of roll to roll and applying products. It's done all day. The technique is getting the graphene off without it ripping and tearing and whatever. So we do not want to say that this is trivial. There's a lot of technique involved with it, and we're reaching out with industrial partners who see what we see to help fund and develop those techniques and get them perfected.
Can I ask you what are your target markets for this? How would you, I mean, you mentioned batteries, how else would you use this? this
The,
type of
the
graphene?
issue with graphene, of course, is that its utility is enormous, and you can really, there's not an industry that essentially you couldn't use graphene in. So the way we target it is we look at 4 key industries, and I always forget them, so I'm just going to read them out. So one of the key ones for us is energy storage, and this whole EV market and energy and static storage is exploding, you know, and graphene has an incredible impact on those, and the end users are starting to become aware of it. So energy storage is a key market for us. Electronics in general is another one, and as you get the 5G and high speed and, you know, optoelectronics and all these kind of things coming on board, electronics is an important market. Then we have the life sciences, the biocompatibility, barrier properties, and the biofilm inhibiting aspects of graphene make it really interesting for the life sciences, for implants, for growing stem cells, for catheters, for lots of different areas, and also for biosensors, of course. Graphene is so sensitive because of its electron mobility that when you attach proteins to it, if it feels that it grabs a coronavirus, it can be detected instantly and with very high accuracy and sensitivity. So those kind of biosensors, which kind of borders on electronics, is also interesting. So you've got energy storage, life sciences, biosciences, and the electronics. And then the final one is membranes in general. Because it's a perfect barrier, if you get a few layers of graphene, you have a barrier even to helium, you know, which is the smallest molecule known to man. And you can poke holes in it. You can get very high selective nanofiltration products out into the market. So we're studying that as well. So these are the kind of centers of industry that we're focused on right now.
So Adrian, is there something else that you want to ask Kevin, or any more questions?
Well, it sounds like, just in summary, that Kevin's got a continuous manufacturing process. How long can you make graphene for, Kevin, in these reels?
As large as the we're constrained for the moment by the width, so a lot of the standard products are 30 centimeters up to 40 centimeters wide.
Yeah.
So our manufacturing is aligned with those widths, and there's no reason why you couldn't go wider if you had wider materials.
But you could
do it as long as you want. So basically the constraint is the carrying of the finished material at the end, and how, you know, the people's own reels, at the customer's own reels, etc.
So you can make graphene on copper foil about that wide, and for what, meters, hundreds of meters probably.
Yes, if you buy 100-meter reel, you get 100-meter of graphene sheet times its width.
This really is industrial.
Well, and that's what's required, right? I mean, you don't knit to make textiles anymore, right? You got textile mills, and they're on cords, they're on twine, right? And they're on bobbins. And this is what you need to do. And what the interesting thing is, Adrian, what we see is once you have that capability cell that can make 100,000, 200,000, 500,000, a million linear feet or square meters, let's call it square meters, you just put them side by side, and then you have an industrial cell. So just like in the textile mills, right? You don't have one weaver, right? You have them all next to each other, and they're all making the textile in the end. And so I'm kind of thinking that I come from that space, you know, and from industry. So I'm seeing it the same way. All it needs is partnership and investment. In my opinion, the rate determining step from the industrialization of graphene now is resources and applications development at the end. So the quicker that we can get this message out and show industry that the technology is essentially there, and come with us to develop finalize the industrial processes and also the application development, the quicker this will go.
So you were right, Debbie. Graphene's gone from impossible to industrial in 16 years.
Yeah, half the time that silicone took to get from discovery to industry.
Yeah.
A lot longer.
Yeah, Kevin, we
My
need to keep in touch and find out what more you do with this stuff. So congratulations and well done.
They can contact me, and we have a new website at generalgraphenecorp.com. There you can contact us, and we'd love to engage with the industry one-on-one and let them know, give them more insight into what we're doing over in Tennessee.
Thank you for your time, Kevin. We appreciate it. It's great to hear what you're doing, and all the best.
Thank you for the platform, and
Yeah.
good luck.